Jai Hind everyone. Myself Pradeep Kumar Tripathi, Assistant Professor in IT Department. Today we have discussed about the DVMS lecture series. We have previously discussed 2 lectures. Now lecture third, we have discussed about the topic of constraint and relational algebra. In the constraint, we can certain type of constraint. Constraint means a set of rules that can be maintained the quality of information. That is called constraint. Suppose we talk about the integrity constraint. What is integrity constraint? Integrity constraint of the rule that can be maintain the quality of information, and integrity constraint ensure the data insertion, updation, and other process that to be performed in a such way that integrity cannot be affected. Integrity constraint is used to guard against accidental damage to the database. This is called integrity constraint, and we can divide the integrity constraint into these types of constraint. One is domain constraint, integrity constraint, referential integrity constraint, and key constraint. These are the main types of constraint which I have discussed in particular lectures in the lecture. In the first part, we have discussed about the domain constraint. What is a domain constraint? Domain means that particular area that we have worked about. So in the database, we can talk about the domain constraint can be defined as the definition of valid set of values for the attribute. What is attribute? Suppose we have a table, ID, name, semester, and age. These are the called attribute. ID is the attribute, name is the attribute, semester is the attribute, and age is the attribute. So if we talk about the domain, what is the domain? Domain is the set of range or set of values that can be exist in a particular attribute. Suppose we have talked about the ID. In particular ID, we have a range of particular IDs. Suppose we have pointed out 1A. That is not valid because this domain cannot accepted letter and integer value. It can be accepted only the integer value, and the ranges started from 1000 up to till the values. So it is called domain. Domain is the range or set of values that can be defined the attribute type or attribute. The data type of domain can be various type of data type. We can have like string, character, integer, time, date, currency, etc. In the value of attribute can be must be available in the corresponding domain. Suppose semester means if we talk about the BTech program, there are the 8 semester program, and the 8 semester program you can put over here first semester, second, third, and fourth and fifth, like this. So this is called domain of particular table. Suppose age has a value of 17, 24, 21, 19 up to the integer value, but age cannot have the value of A because A is a character, and character is not allowed in the particular domain because age has a value of integer like 17, 24, 21, and 19. So domain constraint can be defined as the valid set of values or valid set of range for a particular attribute. Right. Now next constraint is entity integrity constraint. What is entity integrity constraint? The entity integrity constraints state that the primary key value cannot be null. What do you mean by the primary key? In the particular table or particular relation, we can say about these are called the attributes. In this particular table, we have a primary key of employee ID because primary key is the key that can identify the individual row of the relation. That is called primary key. In this particular table, employee name and salary, both table have the value, same value for the, suppose Jack has a salary 30,000 and Harry has a 60,000, but it can be a 30,000. It is possible. So we cannot make employee name and salary as a primary key, but employee ID are the unique. We can pick only the one value corresponding to the one primary key. So, primary key is an attribute that can be identified the individual row. So, in this particular table, employee name and salary, we cannot take that particular attribute, but we can take the employee ID as a primary key. So, integrity constraints state that the primary key value cannot be null. That means we cannot empty that particular field in corresponding row. Suppose we have a 123 Jack and 30,000 and 142 Harry and 60,000, 164 John and 20,000, but we have the value of employee name Jackson and salary is 27,000, but we cannot put the blank space. It is not allowed in this particular constraint. Constraints are the basically condition that can be applied to the particular table. So, integrity constraints are there. Integrity constraints state that the primary key cannot be null. A table can contain a null value other than primary key field. We can put over here null value, we can put over here null value, but we cannot put over there, because if we have null value, then we cannot relate that particular row in a particular ID. We cannot access that particular row. Suppose we want to record of Jackson and his salary. We cannot relate that particular record to the primary key, so we cannot access that particular row. So, this is called integrity constraint. So, we have read about the domain constraint. Domain constraint means we can define as the definition of a valid set of values for an attribute, and it can be varies from integer, character, time, date, currency, all these types of data type we can use. So, domain and integrity we have covered. Now, we have third type of integrity constraint. This is called a referential integrity constraint. What is a referential integrity constraint? A referential integrity constraint is specified between two tables. That means we have a two table. One table has a primary key or another table has a primary key, but both tables have a relationship in between them. Suppose we have a table number 1, we have a table number 2, and we have in the particular table number 1, we have this type of attribute: employee name, age and department number. And we have in the second table department number and department location. These are the two attributes, and we have connected that particular two tables with the help of this attribute: department number, both are the common in particular, in a particular table, and we can join that particular tables with the help of department number. In the referential integrity constraint, if a foreign key in a table 1 refers to the primary key of table 2, that every value of foreign key in table 1 must be null or available in the table 2. Every value of the foreign key in table 1, every value must be null or available in the table 2. This means we have a value of 11, 24, 18 and 13, and here we have a value of 11, 24 and 13. This value can be exist in table 2, 1, 2 and 3, but this value cannot be available in table 2. So, not allowed as a department number 18, not defined as a primary key of the table 2. So, in the table 1, department number is a foreign key defined. So, this 18 value cannot be accepted at all. This is called referential integrity constraint. We cannot relate that particular 18 value of table 1 to table 2. So, this is not allowed, and both 3 values are allowed, 1, 2 and 4, these are allowed, but this is not allowed. This is called referential integrity constraint. Constraint means that particular condition that can be exist in a particular table. So, this type of integrity constraint we have discussed: domain, integrity and referential integrity constraint. And next one is key constraint. Key, what are key? Key are the entity set that can be used to identify an entity within its unique set. Or you can have an entity set can have multiple keys, but out of which one key will be the primary key, and a primary key can contain a unique or null value in a particular relation. That is, we have ID, name and semester and age. These are the value of IDs, these values are the name, and these values are semester and age. So like that. Suppose we have a value of 1002 and 1002. These are the two values. All row must be unique, but we have duplicate of these two values 1002 and 1002. This is not allowed. We have a primary key contain the unique null value in and null value in the particular relation, but duplicate value are not allowed in the particular single table. So in this particular table, 1002 have two entries that is not allowed in the particular table. Only one value can be allowed. This is called key constraint of particular table, not primary key constraint. It is key constraint. It is the key concept. You have the unique value corresponding to the table. So if you maintain the particular table in a DBMS architecture, then you have to mention one value to one corresponding column. Not repeating entries are allowed in the particular database or particular table. So this is called key constraint. So we have discussed about the domain constraint, then we have discussed about entity integrity constraint, and next we have discussed about the referential integrity constraint, and lastly we have discussed about the key constraint. Now we have move on another topic that is relational model concept or relational algebra concept. We have lots of operators and lots of symbols that we can use to solve the query of relational algebra. So, well, we have talked about the basic concept of the relational model. After that, we have discussed about the relational algebra queries and their uses with the help of operators. So, first of all, we have discussed about relational model concept. What is relational model? Relational model can be represented as a table with the columns and rows. What do you mean by relation? Relational basically that is a table. Suppose we have a attribute of A, B and C. This is called table 1. This table is called as, in the relational algebra theory, is relational relation. It is called a relation. In the DBMS form, it is called table, but in the relational model, we have represent table as a relation. So if we talk about the relation, that means we have talked about the table. So relational model can represent as a table in column and rows. Every row is known as a tuple. We in the particular table, we have shown about that this is a first row, second row, so on. So this particular row is called tuple. This is called tuple in particular relation. In the particular scenario, if we talk about the table, then it is called in the particular table, row is called row, but in relation, row is called tuple. Each table column name has name or attribute. This is called attribute in the particular table and relation also, but no change in the particular column, but in the row, we have talked about the tuple. So first of all, we have talked about the domain. Domain I have already discussed in the particular domain constraint. It contains a set of atomic values that can attribute can have take the values. Now next is attribute. What is attribute? In a particular table, if talk about attributes, suppose A, B and C, these are called attribute of that particular table. That means it contains the name of the column in a particular table. Each attribute must have a domain and must have a domain values. So attribute name should be unique and should be conceptual. Not generally randomly you have said about the A1, A2, A3, that cannot be meaningful. So it is try to make attribute name meaningful so that everyone can access that particular database or table. They can easily understand what is the attribute and what is the domain and what is the instance schema and so on, key or primary key. These are the concepts. So you have to mention some meaningful name in a particular attribute. So what is relational instance? In the relational database system, the relational instance is represented by the finite set of tuples. Relational instance do not have duplicate tuple. Tuple means rows. So you have to mention some fixed number of tuples. You cannot undefined number of tuples you cannot allow. In particular relation, it is not allowed. So you can say about that these are the two rows and so on up to not defined by the limits. So it is not allowed. It is allowed a finite number of tuples. No duplicate tuples are allowed. These are the two conditions when you have to define a particular table rows in a particular relation. So you have to define two set of values, finite set of tuples and do not have the duplicate tuples. These are the two important points that we have discussed in the particular instance. When we make the particular relation or when we make to the particular table, we have to define some finite set of tuples and do not have the duplicate value. This is called relational instance. What is relational schema? A relation schema contains the name of the relation and name of all the column or all the attributes which I have defined. That means a name of the relation and name of all the column and all the attributes. This is called relational schema. Relational keys, each row has one or more attribute. It can be identified a row in a relation uniquely. So this is the called concept of relational model. When we use the relational model, we can use this type of terminology in particular model concept. So this is some example of particular relational model. We have a student relation. In the previously we have called about the table, but here relational model we have called about the relation. So student relation has a five type of attributes: name, roll number, phone number, address and age. These are the particular called attributes or columns. And this particular rows, tuple 1, tuple 2, tuple 3, tuple 4, tuple 5. Yani suppose T1, T2, T3, T4 and T5. These are the some tuples are there. And what about the instance of a schema? The instance of a schema, what is the name of schema? Schema name is student. Particular table name is called schema. So instance of schema student has a 5 tuples. In the particular T3, we talk about the values of T3. What is the value of T3? Lakshman and 33289, and these are the phone numbers, addresses and age. So this particular instance T3 has the value of this particular. So if we talk about the instance, suppose a person can ask the question, what is the value of instance of T5? What is it means? It means the value of particular time series T5, what is the value of current row? So we can talk about at that particular time T5, we have the value Ganesh, roll number, phone number, address and age. This is called particular row or particular tuple. So this is called relation, student relation. What is the property of relation? The property of relation, name of the relation is distinct from the all other relations. Each relation cell contains exactly one atomic values. Each attribute contains a distinct name. An attribute domain has no significance. Tuple has no duplicate values. And order of tuple can have different sequence. So, this is the property of particular relation. Suppose we have defined about the particular table or particular scenario, you have to maintain these type of attributes of a particular relation. You have to mention distinct relation name, you have to maintain the cell contains exactly one atomic value, and you have to attribute domain, tuple has no duplicate value, and order of tuple can have a different sequence. These are the properties of a particular relation. These are some constraints we have used in a particular DBMS. Suppose first one is null, unique, default, check, primary key and foreign key. We have the 5 type of constraint that we have to use in particular constraint in a DBMS. Suppose not null and null, that can be specified column does not have a contain a null values, and unique, provide a unique or distinct value to the specified columns, and default values to a column if none is specified. Check the predefined condition before inserting the data into the table. Primary key, you have to uniquely identify a row in a particular table and ensure the referential integrity of a relationship. So, these 5 type of key constraint that particular we have to use in particular table. Now, we have some query concept. We have used the particular relation. So, query languages in which user can request information from the database. These are the 2 types of queries. One is procedural query, another is non-procedural query. Procedural pure languages. What is pure languages? Relational algebra, tuple relational, domain relational. These are the pure languages. Pure languages from the underlying basis of the query language that people can use. This is the query concept. And relational algebra. Relational algebra is a procedural query language. It gives the step-by-step process to obtain the result of a query. It uses the operator to perform some queries. So, we have talked about the relational algebra. In the relational algebra, we have used the concept of relational model, and relational model we have used the particular relational concept. So, type of relational operation, we have used these type of relational operation when we have to particular project that particular query. Suppose we want to select operation, project operation, union operation, set intersection, set difference, Cartesian product and rename operation. These are the particular type of relation which have to use in particular relational algebra. In the relational algebra, that is based on the relational model concept, which I have already discussed in relational model concept. So, these are the some operations we have to perform in particular relational algebra topic. So, these are the operators when we can use these type of operators and find out the query of a particular relational algebra query. Suppose we have a select operation. What is select operation? It select the operation, select the tuple that is satisfy a given predicate. It denoted by the sigma. And sigma PR, what is P? Sigma is used for the selection prediction, R is the relation, and P is the propositional logic which may use connectors and or greater than equal to, or some operators we have used equal to, not equal to, greater than, less than or equal to. These are the operators we have used in the predicate logic. So, we have a table, suppose we have a table of branch name, load number and amount, and we want to the particular record of particular table. In this particular table, we want to record a peri-right branch. So, how it can be accessed that particular record? We have to mention sigma, and this is the branch name, that is the column name, equal to peri-right, and this is the called relation name, relation. So, when use this particular query, then we have the output of this branch name, load number, amount number. So PERI-RIDE is the branch that particular selected in particular query, and loan number and amount. This is called selection operation of a particular relational algebra. So this is selection query of particular selection in a relational algebra. These are the called select operators, and you have to perform like this. Now second operation is project operation. What is project operation? When we want to access that particular attribute, we want to access that particular column name, then we have to use the project operation. And project operation is denoted by pi and a1, a2, an, and r is the relation particular name. These are called the attributes. We have to perform like this. Suppose we have a table of this, and we have to perform 2 A and C, then we have output of this particular project operation. Project operation is basically used for the selection of attributes, selection of columns. Then we have to use this particular project operation. Project operation performed by this. Suppose we have eliminate the branch name attribute to the account. So pi, account number and balance, and this is called a particular project operation. Next is union operation. What is union operation? There are two tuples R and S, and the union operation contains all the tuples that are earlier in the R or S, or both R and S. These are the some necessary condition which I have to mention in the particular union operation. R and S must have the attribute of the same number, and duplicate tuples are eliminated automatically. Suppose we have two tables, and you have to pi customer name borrow and union pi customer name depositor. These are the two tables which I have to combine that result. So we have a project operation of this particular, and here project operation of this particular, and then we have to combine by the using of union operation. So you have performed like this in union operation. Suppose set intersection. Set intersection means the set intersection operation contain all the tuples that are in both R and S, and denoted by this. You have to denoted by this symbol in R and S. These are the set intersection operations. Set difference. What is set difference? That contains all the tuples that are in R but not in S. Suppose we have written like this. So we have contained all the tables, all the data of R, but we cannot include the data of S. This is called set difference table. So we have to use pi customer name borrow and minus pi customer name depositor. These are the called set different operation that can be performed in particular scenario. What is Cartesian product? We have the Cartesian product we use to combine each row in a particular table with the each row of the other table. You have to cross product of that particular table. Suppose we have the two tables E and D, and we have to find out E and D. So we have all about the Cartesian product, and after the Cartesian product, composition and rename operations are also there. So these are called all the operators that we have in defined particular relational algebra. So this is the concept of relational algebra operations. Now we have discussed next lecture series in further. Thank you.